Thank you. Thank you. First, thank you very much for the invitation. And it's a great opportunity, especially present in front of George. So the starting point of this work is we realized that there were quite some withdrawals of countries from international organization and agreement. For example, July 7th, 2020, the Trump administration notified the UN to withdraw from the WHO, and effectively one a year later. Of course, later when President Biden in office, the withdrawals was stopped, but it happened. And June 1st, 2017, President Trump announced that US ceased all participation in the 2015 Paris Agreement on climate change mitigation. Of course, the first day President Biden in office, changing this decision again. Anyhow, we saw the two directions, the join and the leave. And UK, more seriously, UK withdrew from the European Union on January 31st, 2020. And we also saw Canada withdraw from the Kyoto Protocol on the December 13th, 2011. Though they already joined the Copenhagen Accord in 2009 and later the Bonn Agreement later. From the level, we saw even more this kind of merging and separation. For example, the October 2014, the technology gigant HP separated into two part, the computer and printer business separated from the hardware and the service of the operation. And this kind of separation eliminated about 5,000 jobs. And July 2015, the PayPal spin-off from the eBay said that PayPal can serve the other online service, and eBay at the same time has a freedom to use the other online payment as well. So facing this kind of withdrawals from different kind of organization, there are already a lot of studies, but this group of studies mainly based on gain and lose. For example, for the Brazil situation, Oxford Review of Economic Policy has a particularly special issue studying this problem. And there were also a group of studying about the consequences when the US withdraw from the Kyoto Protocol and Paris Agreement. And in 2020, Journal of Monetary Economics published a theoretical paper about the gain to be inside an economic union or outside of it. It's kind of you are in the club or outside of the club. What is the gain? What is the lose? But those group of literature are not based on particularly about international agreement or coalition. The literature related particularly to this issue, that is a coalition, mainly two branches. One is based on the Nash non-cooperative game theory, kind of criteria of Pareto efficiency and so on. The other group is about the coalition stability. Here still two branches. One is a static or repeated game, mainly actually in core, the institute in core in Belgium has quite some scholars and professors working in this topic, is mainly considering core stability and the internal external stability. In this case, the size of the coalition is important. Another branch is based on differential game, that is, this paper is going to follow, is mainly pioneered by Patrician work, was trying to search for sharing mechanism or a kind of time consistent strategy. And George here is the specialist. I'm kind of show off in front of the master, but we deviate from this group of literature in two major ways. The first one, our sharing rule, the sharing strategy within the coalition is not necessarily setting by any optimality or stability condition. It's rather initially set as constitution rules. Second is a player initially behave as if the coalition will last forever. We do not initially assume someday the coalition is going to finish. So somehow the setting is a lot of like marriage with great expectation, commitment, and it will last forever. But just shit happened, separation happened. That is also some kind of situation, the payment of UK withdrawal from the EU called the divorce bill. So the idea behind this one is that we consider the players has some differences among them. For example, technology development level are different, the history different, culture different, even institution or geography difference. And so it's unlikely at the beginning of the coalition that the sharing rule is set which satisfies kind of optimality and is changing over time to satisfy all these situation. So we are not talking about Nash bargaining. We are not talking about Shapley value, which can guarantee the time consistent and stability. Rather, we are thinking about initially taking into account these differences and different players initially. They play actually cooperatively and optimally to support the constitution. But if the constitution rules are not renegotiable or the renegotiation is too costly, then with time passing by, some players are not happy about it. For example, the Paris Agreement, if US is not happy, the rule they found is not fair, we need to sit down and renegotiate. It will be very difficult to do it. And the same for UK withdrawal from the EU, because UK is not happy, the EU need to change the rules. The next time will be Italy is not happy, the next time will be France, then is unmanageable. So that is the situation we try to measure. So the basic assumption is a group or set of countries initially bounded into a coalition to maximize kind of joint welfare, which subject to some constraint could be public bad or public good. And the sharing rule is based on some constitutional rule, the benefit or the cost. And this rule is time invariant. And then our research question is, under which condition a country initially belongs to this coalition may eventually leave it in finite time, and when this happened. And the second question, what are the determinant of this separation and the duration of the coalition? And obviously, how to prevent the breakdown of the coalition. So we set up what in our mind is the US, the withdrawal from the Paris Agreement and UK splitting from the EU. That is what in our mind. And we're using the international agreement to telling the story, which make it easier. In the international agreement literature, very often the time when the agreement is facing trouble and so on is not explicitly modeled. Very often is considered as kind of equilibrium situation. But there are two papers closely related to us, both related, are co-authored by Professor Wan Long. The last one is published last year in European Economic Review, investigating about the partial cooperation in international environmental agreement. In that setting, all players are identical. So the share of each player in the joint welfare it doesn't matter it's a partial cooperation or full cooperation. If it's a share initially, then if it's fair initially, then it is fair later. But for our case, we particularly take into account the players are heterogeneous. The second one, paper published in Journal of Environmental Economics and Management in 2006, studying the temporary nature resource cutter. Again, this is a temporary, so the ending time of the cutter is known to all the players at the beginning of the game. But in our case, when the cooperation finish, depending on one player's choice, which is endogenous variable. Before I present the model, one thing should be clear that in our setting, there are some challenge of the decision maker, because we have two stages during the cooperation and the competition. So it's kind of a multi-stage optimization or multi-stage differential game. In the classical literature, the multi-stage optimization, the decision maker is the same one. That the stage taking new technology, do not stay with the new old technology, the regime switching faced by the same decision maker. But in our setting, during the cooperation is a joint decision. But after the cooperation, it is a competition. So the decision maker changed. And obviously, after the cooperation between different players, the strategic space is an important issue. So here, I will come back to this point later. In the later setting, the main part of today's presentation, we're focusing on Markovian strategy. Both players will choose to play Markovian strategy if the separation happens. Okay, the model. So initially, there is one block. So we do not consider the stability of the block. We do not forming the block. We assume when we try to study the issue, the block is already there. Obviously, when to form a block, that is another story. That is a different paper. We have two players, I and capital J. Player I may quit the block at some future day T, which is not yet known. It may happen in finite date. It also could be T equal to plus infinite. That means it never happened. And the rest of the block is named capital J. Obviously, it could be just one player and then the rest is N players. Theoretically, there is no big difference. And the unique finite, that both players produce one final consumption goods, and the pollution is the only input for the production. And each player produce final good with CO2 emission as a byproduct. And each player emit xj unit of pollution. And the two players share the cross-boundary pollution Y, which is this utility. So initially, the joint welfare is considered as from time from 0 to infinite. And the utility, we simply added the two together to make things easier. Player I's utility, player J's utility, and they facing this utility because of pollution. And they subject to the same state constraint, the pollution emission, natural self regeneration capacity delta, and Y0 initially when we starting the coalition is given. And here, the share alpha is player I's share in the total welfare, and the rest 1 minus alpha give to player J. So here the time is considered, as we said, is like a marriage. It will last forever initially. As we said before, alpha is fixed at the beginning of the coalition, is time invariant, and is independent of the contribution. One of the thing the President Trump was not happy is US contribute too much, and so it's not fair. And again, alpha is not by any kind of Pareto weight or Shapley value, and so on. And renegotiation is not possible. Okay, so when the cooperation, when player I decided to quit the yes.
May I ask a question just to understand the role of this alpha? So alpha, yes, for the time being is a given parameter.
Yes.
And yes, I guess you will look at some sensitivity analysis to understand, yes, its impacts. Okay.
Yes. Yes.
Okay,
yes.
I got it. Thank you.
It's a main parameter will play.
Okay. Thank you.
Yeah. Thank you. And if player I quit the block at time t, obviously after the quitting, the two players, as we said, became competition. At this stage, it not matter which strategy space they choose, they are going to maximize their own welfare, benefit, and cost. And the state equation is the same. It's just after a capital T. And if the player I quit the coalition in finite t, then the t is an optimum choice given by the first order condition. So here is the first order condition, but of course we need to check if the second order condition holds. If the second order condition holds and t is finite, and then we get the optimum time for player I to leave the block. Intuitively, the first term here should be non-negative in the sense that the longer the time period, the more the aggregate social welfare. But there is no guarantee it's always that case. We'll come back to this point. And the second term here should be non-positive in the sense if t is larger, which means the first cooperation period is longer, then the second period, the competition period is shorter, and the shorter the period, the less the social welfare. Otherwise, the shorter the period, the larger the social welfare, player I will not quit the block. Then the coalition should last forever. So we will basing on this to choose the time. And implicit function theorem says that if this is necessary condition, if t is indeed finite, actually the separation time is increasing with respect to alpha, meaning if player I has a larger share in the aggregate social welfare, actually the coalition will last for longer time period. Obviously, the question is how large is large enough? Alpha, should alpha equal to 1 or alpha equal to 0.9? How large is large? And here we must be careful. T is not a truncated terminal condition. It is an optimum choice. And before and after T, the decision maker changed. That's as what I said before. So, yes.
I have a question.
Yes.
So here you are looking at a specific country leaving or not, and that country has alpha as this power in some way to in negotiations throughout the planning horizon.
Yes.
Okay.
Yeah.
Thanks.
Obviously, if without further assumptions, we can't do more. So we rely on linear quadratic functional form. Obviously, there is a constraint because we choose the explicit functional form, but it gives us some explicit result. It illustrates some information. So we use the utility function is linear quadratic. The AJ XJ is a production. AJ could consider as the technology, translate the pollution into consumption goods. So the higher J, the more advanced the country is because they can convert the same of amount pollution into more consumption good. And this production has a cost. And the pollution damage is also taking the quadratic form. And B is a constant. And both the development level AIJ and B are parameters will be important for the decision. Okay, the first result is about the joint social welfare. As we said initially, the coalition was supposed to last forever. And then obviously it is a very easy exercise. Linear quadratic optimization is no game. Optimization, we can easily obtain the optimum emission rate IXJ for both players and the optimal trajectory of pollution accumulation and the long run state of pollution accumulation. And it is asymptotically stable and pollution is monotonically increasing over time. So this part is rather easy. And if player I quits block at time t, the pollution is starting from at this level. Okay, and t is not yet known. It should be whatever it is, it will be starting from here. Yes.
Sorry, Benteng, to interrupt. Can you go back to the previous slide?
This one?
Okay, so here it is the joint optimization.
Yes. Yes, during infinite time horizon.
Infinite time horizon, and okay, it's nice the way the XJ is written because you are highlighting the role of AJ. So this is what I wanted to say. Thank you.
Yeah.
Sorry for the interruption.
No problem. Okay, so we check, as we said, is important choice is how the social welfare changes over time. And we investigate this one, how the social welfare during the cooperation changing over time. And it is end up as a linear quadratic function of YT. And it is not always, of course, that is due to the linear quadratic setting we had, but it's not always larger than 0. As we said, intuitively, it should be non-negative. Otherwise, the separation should happen before that. And this increasing over the time, the duration of the cooperation, only if YT is in between 0 and Y bar. Okay, and Y bar is given by this combination of parameter depending AI and AJ and also B. All the others, B, AI, and J also appeared in the capital BC, what is appeared here. And this Y bar is very important for our study. So two strict corollary. One is if the initial condition is already over the Y bar, initially is already over this one, which means this is decreasing with time, then the coalition actually should not even exist. Because the anti-coalition is already in the joint social welfare decrease. So the T should be 0. But obviously, if in the long run steady state, the coalition long run steady state still lower than the Y bar, still in the domain such that the social welfare is increasing domain. And then from this part to C, actually the T should be infinite, which means that the duration of the coalition should continue. But obviously, we also need to consider the second part. So to make it easier, we assume, if we want to consider infinite time separation, we assume initially Y0 is lower than Y underline, and which is lower than Y star, such that infinite time separation became possible. And before we go further, we investigate two special cases. One is both AI and AJ are relatively low. That is a situation, low development situation. And Y underline actually is 0. and you give any initial pollution situation actually is larger than Y0, Y underline. So in that sense, if the two countries or the two part players, the development level are sufficiently low, the coalition hardly exists because neither of them can benefit much from these activities. Then there is no incentive. They cannot do much for the environment. The second situation is if the damage B is very low, that is the B is closer to 0. The damage is low, then Y underline actually goes to plus infinite, obviously is larger than the long run steady state. So from what we said before, the coalition should last forever, but intuitively, if the cost from the pollution is almost 0, no cost, there's no point to have a coalition to start in to control the pollution emission, is rather doesn't exist. The reason is, in this case, the cooperation and competition actually almost identical. The benefit for player I is the same if B equal to 0. So if there is a coalition there, just stay in there because it doesn't change anything. But if there is no, then no point to start a coalition. So the second result. Now we are entered the stage of competition, given it is starting from time t until infinite, so it is linear quadratic game, infinite time horizon, and so on. So it is still easy to get at least the stable affine Markovian perfect strategy. It is, but it looks similar to the cooperation situation, but obviously the value changed. And we can get the optimum state trajectory and also the long run steady state of pollution. And one direct result is the cooperation is still doing better than the competition, whatever the parameter situation. So that is a classical result saying that the cooperation, at least in control of pollution emission, can do better than the competition. So the decision to leave the coalition by player I is not based on the others didn't make enough effort. There are other reasons. So let's check the other reason. Player I leaves the coalition. The social welfare is not always increasing over time. Is always not always decreasing. So the larger the time should be theoretically, intuitively should be the smaller the social welfare of the second period because the period is shorter. But it's true only when YT, that separation moment, that pollution accumulation reach to the between the 0 and Y overline. If YT, that is thus when player I would like to quit from the coalition, the pollution is sufficiently high. Actually, the pollution player I should stay with the coalition because the social welfare is increasing with T, meaning the longer the duration of the coalition, the better for also the second period social welfare. So, but the relationship between underline Y and overline Y, it is not clear. So we assume, as the second assumption, initially Y0 is lower than Y bar, such that the coalition may happen in the finite time. Otherwise, if Y0 is larger than Y bar, the coalition is dealing with the pollution control and the coalition will last forever. So with this assumption 1 and 2, we can work on the first order condition. Again, because of the linear quadratic setting, the first order condition end up with a second order polynomial of pollution at the moment y. The M is just to state it is Markovian strategy. So YTM is the pollution level at which the coalition player I would like to quit from the coalition. And the three parameters, lambda, sigma, and gamma, all depending on alpha. Though the previous ABC, the capital ABC and so on, they are independent of alpha, but all those parameters depending on alpha. Then the root, the first order condition, the root here, YTM, obviously depending on alpha. How big the share determined when the player I will quit from the coalition. And to guarantee this YTM is real, positive, all different kind of combination together is lambda less equal to 0, gamma larger equal to 0. And this condition also guarantees the second order condition hold. So the YTM indeed give us the unique moment player I quit from the coalition. And these two inequality condition can translate into two ugly condition. One is alpha larger than GB, except the R delta gamma C only depending on B, R and delta. So B is the key parameter here. And the second condition, inequality can translate into alpha larger than this ugly form, but again, it depending on B, the damage from pollution and the technology gap or development gap. That's what we said. We take into account the heterogeneity among different players. So here, indeed, alpha has this kind of property. The share should be larger than this, guarantee we have a point for separation in finite time. And, but there, as we can see, the two conditions are pretty ugly, but we dig a little bit deeper. GB is increasing with B and G0, B equal to 0, that without cause, GB is 1/2. Which means alpha should larger than 1/2. That is a situation because we only have two players, is more than half of the share of the joint welfare should go to player I. If we have n player, this one should be 1/n. So it is more than the average. That other situation, it is ugly to say what is the situation, but we will come back to this point to see some other situation. But with this situation, we have a sufficient condition. If the parameter alpha share certified this, that's what we said for the first order condition to hold and second order condition, of course. Alpha obviously is a share should strictly less than 1. And the parameter combination such that the roots of the first order condition is between these two, initial condition and the long run steady state, then there is unique time, which is given by T positive for player I to quit from the block. So, and obviously the time given YTM, as I said before, depending on alpha, the time to leave depending on alpha as well. Now, two special case, because the general condition is kind of ugly, we consider two special case. One is player I is the lagging country. The other one, player I, is the leading country, to see if these two cases will still player I quit from the block or not. And in the first case, player I is a lagging country, that is the ratio AI larger than AJ. As we said before, even be equal to 0, alpha should larger than half, we could consider player I is a larger economy, and it quit the block only depending on the cost. So alpha larger than GB, the technology gap, given it's a lagging country, the technology gap will not be the main issue. But the big economy here may quit the block if the share is sufficiently large. And if player I is advanced economy, still need to be large, and actually take into account, the player I will take into account its advantage, because the other lagging country will benefit from him or her. And so actually the quitting condition will be dominated by both the damage and the technology gap. The more advanced, the easier, and require more share from the joint welfare, and essentially will quit from the coalition. The question is, how we can, theoretically, the coalition is trying to deal with the pollution control. What is a way we can increase the duration of the coalition? And this here we have a result here. If there exists alpha 0 between 0 and 1 such that the quitting moment indeed is happening, this between 0 and y underline is the interval such that during this period, the joint welfare will increase with the separation time or the duration of the coalition. If it's happened that the quitting moment is indeed in this one, the YTM is alpha function is increasing in alpha. What is that supposed to mean? It means, recall, in assumption one say quitting should be, if quitting happened, the Y should belongs to this group. Okay, so the lower bar situation. And our assumption here saying, if there exists a share alpha 0, this indeed is a function of alpha such that separation indeed happened. And then actually we should increase player I's share such that when the quitting happened, the solution is, the pollution, accumulated pollution is at higher level. At a higher level, recall the pollution accumulation is monotonically increasing over time, it meaning the duration of the coalition is larger. And the postponing of this one obviously will increase the joint welfare of the coalition. But obviously, in this case, player I will have more benefit because its share alpha increase and the period T also increase. But there is no guarantee for player J. Though the joint welfare increase, but the player J's share decrease. So there is no guarantee. Even for player I, is no guarantee the second period, the welfare will, the loss in the second period can be compensated by the increasing of alpha or not. But that is a way such that giving alpha player I more share in the joint welfare, it could hold alpha the player I a little bit longer in the coalition. But given we don't have the renegotiation possibility, it's just could be a suggestion. But previously, the result is sufficient condition alpha larger than the maximum of these two, player I is going to quit. Obviously, if alpha is smaller than these two, the minimum of these two, the coalition could last. And obviously, as we said before, alpha, the one who would like to quit, always the larger economy. The alpha should larger than half, or the one who get more than the average of share if we consider n player situation. That's about the case where we consider both players after the separation plays Markovian strategy. But it could be the situation that after the cooperation, even quit from the coalition, both players still commit. That is, both plays open loop strategy. Behind our mind is a situation of Canada withdraw from Kyoto Protocol, but still committed to make an effort to decrease the CO2 emission. But obviously, it's also happened player I plays Markovian strategy, but the remaining block, the player J plays stick to the previous commitment. That is a situation when US withdraw from the Paris Agreement, the other country did not immediately, at least, adjust the strategy, the commitment. So obviously, given player J stays with the initial commitment, it may not be subgame perfect Nash equilibrium. So it is from player J, maybe it's not the best, but commitment is commitment, need to be respected. Of course, there is also the other situation that is player I plays Markovian strategy. Player J knows that, and anticipating, player J make a commitment, but anticipating that player I is going to adjust her strategy. So player J's strategy take into account player I's strategy, which could form kind of subgame perfect Nash equilibrium. This is a situation come to our mind because after US withdrawal from the Paris Agreement, some scholars did some simulation that what the other country should do in order to reach to the original target, given US is going to play Markovian strategy. So that is this situation. Our method, the calculations are exactly the same. Doesn't matter which strategy space you have, but the outcome are different. Here, we just did some simulations. It's not calibrating anything. It's just even the parameter doesn't need to make sense in reality, but we illustrate some situations, further investigation still needed. Here, the two players actually had the same development in this figure, the same level of development, that is AI equal to AJ. The only difference is the cost parameter B. Here is, let's say we say the lower cost, this one is a little bit higher cost. And what we see, the timing from the upper, we already can see the T, that is the time to leave the coalition. And in this case, when the cost is low, the left upper corner one, actually, if you choose Markovian strategy after the coalition, leave the coalition earlier than if player I plays Markovian strategy, player J stays with commitment. But if the cost is higher, cost parameter is higher, the opposite is true. If player I plays open loop strategy, player I plays Markovian strategy, player J stay with commitment, leaves earlier than both of them plays Markovian strategy. And why is that? We don't know actually. And from the social welfare point of view, at this simulation, player I always do better than both of them plays Markovian strategy. So indeed, in this case, it seemed the choice of player I to live is indeed based on better social welfare. But if we change the situation where the damage is the same, but the development level are different. Here, the player J's damage is 0.1, development level is 0.15. Player I on the left part is 0.2, the right part is 0.175. As we can see on the upper two figures about time, both Tm is above Ti, but the social welfare changes. It's different from the previous figure. So what the precise reason behind this one, which strategy dominate, we cannot say at this moment. At a different situation, we should separately study. As the conclusion, using two-stage game or two-stage cooperation to cooperation to competition, we can investigate how long the coalition will last, what are the conditions such that the separation happen in finite time. But we cannot answer which situation, which strategy should be chosen by different players, and in which sense, which strategy is better. That is one of our next research questions. What kind of strategy we should recommend it to the players? The second question related to what we are doing is what happened during the coalition period? There is already another competition. The behind idea is when UK left EU, there are other countries would like to join EU. Obviously, UK is different from the other country would like to join EU, but why the EU is good for some other country, but not good enough for UK? Does this kind of extra competition changing the duration of the end of the coalition, or not at all? Those are the future works. Thank you very much.